Today we're looking at this webinar summary, Wireless Connectivity, Enabling the Next Industrial Revolution. It's from the Alpert research team. And it really dives into the convergence of wireless communication with Industry 4.0 and 5.0. The core idea seems to be that wireless isn't just supporting this shift, it's actively enabling and accelerating it, connecting everything from, factory floors to entire global supply chains. We'll touch on key technologies, 5G, 6G, Wi-Fi 7, LPWANs, and some advanced stuff like flexible numerology and ISAC, integrated sensing and communication, all crucial for these intelligent, interconnected, and human-centric industrial systems.
So Industry 4.0, the fourth industrial revolution, that's fundamentally about merging the physical and digital worlds. Think automation, connectivity everywhere, using data for decisions. The main goal is, well, efficiency and productivity. Humans are often monitoring or maintaining the automation.
So what does Industry 5.0 add? What's the evolution there?
It's a really important evolution. Industry 5.0 goes beyond just efficiency. It brings in societal well-being, sustainability, resilience, big focus on human centricity, things like worker welfare, aiming for zero waste, mass customization.
And the human role changes.
Exactly. Humans become partners with technology. You hear about cobots, collaborative robots working right alongside people. It's less about replacing humans, more about augmenting their capability.
And underpinning both these revolutions is wireless.
Wireless is foundational, yes, but it's not about picking just one technology. The smart strategy is using what we call a heterogeneous network, meaning a mix of different wireless technologies. You select the right tool for the right job, depending on the specific application's needs. 5G is definitely essential. It offers three key things: enhanced mobile broadband, EMBB, for high speeds. Then there's ultra-reliable, low-latency communication, URLLC.
URLLC, that's the one with near-instant response times, right?
Precisely. We're talking sub-millisecond latency and extremely high reliability, like over 99.9%, crucial for real-time control, like robotics. And the third is massive machine-type communications, MMTC, which lets you connect a huge number of devices, maybe 1 million per square kilometer. Think sensors everywhere.
That reliability, the URLLC part, why is that such a big deal in a factory?
Well, imagine you need multiple robots to move in perfect sync, or an emergency stop has to work instantly. You need that guaranteed deterministic performance. It's absolutely vital for safety and smooth operation.
And looking ahead, what's the promise of 6G?
6G. It's still on the horizon, but the potential is staggering. Terabit speeds, potentially near zero latency, and reliability maybe up to 9 nines. 99.9999999%. Plus integrated AI and really advanced sensing capabilities using things like terahertz frequencies for, say, super precise defect detection.
What about within the factory walls for high bandwidth needs?
That's often where Wi-Fi 6 and now Wi-Fi 7 shine. Great for things like AR/VR headsets for workers or high-definition video monitoring. Wi-Fi 7 adds features like multi-link operation, MLO, boosting speed and reliability.
And for simpler things, like tracking assets.
Yeah, for long-range, low-power, low-data stuff, you have LPWANs, low-power, wide-area networks. Think technologies like NB-IoT or LoRaWAN, ideal for asset tracking, environmental sensors, metering, things that send small bits of data infrequently. And then even shorter range, you've got Bluetooth, Zigbee, Thread. These are great for low-cost mesh networks of sensors.
So it's really about matching the tech to the need. How do some of the advanced features like millimeter wave help?
Right, so millimeter wave or MM wave and even terahertz, they offer huge bandwidth. Great for data-intensive apps in smaller areas like holographic communications for remote experts or ultra-high-def video for quality inspection. Then there's massive MIMO and beamforming, often used in 5G.
That helps cut through the noise in a busy factory.
Exactly. It focuses the signal, improves performance, boosts coverage, reduces latency, especially in those really dense, complex industrial spaces.
And you mentioned deterministic timing earlier. How does wireless achieve that reliability needed for industrial control?
That's where integration with time-sensitive networking, or TSN, comes in. TSN is a set of standards, mainly from the wired Ethernet world, guaranteeing timing. Integrating 5G with TSN allows wireless to offer that same guaranteed, predictable performance. It bridges the gap, basically, moving wireless from just best effort to truly deterministic.
Okay, let's ground this. How does this translate into real-world applications?
Well, flexible manufacturing is a big one. Wireless means you can move robots, AGVs, reconfigure lines quickly without ripping up cables. Then there's predictive maintenance.
Using sensors to predict failures.
Wireless sensors feed real-time data into AI systems, predicting failures before they happen. Some studies show this can cut downtime by like 35–45%.
And things like digital twins.
Perfect example. Constant, secure wireless data streams keep those virtual models perfectly synced with the physical asset in real time. High bandwidth wireless also enables AR/VR for training or remote expert assistance, and it's key for those human-robot collaborations, the cobots we mentioned.
What about beyond the factory, supply chains?
Big impact there, too.
Yeah.
Real-time tracking of goods globally. Better visibility means fewer delays, less wasted inventory.
But surely there are hurdles. What are the main challenges?
Oh, definitely. Cybersecurity is paramount. You've suddenly got this massively expanded attack surface with all these connected devices. You have so many different systems, different protocols, you need bridging solutions, and strong open standards like OPC-UA, often running over TSN, to ensure seamless communication and just achieving that guaranteed deterministic performance consistently with wireless, bridging that gap from best effort remains a key focus area. So, Industry 5.0 isn't just some far-off idea anymore. It's actually happening now, it's evolving, and wireless communication is right there at the heart of it, enabling it all. Organizations that really lean into wireless innovation, they're the ones who will unlock smarter production, more resilient supply chains, and ultimately create value that's sustainable and human-centric. As this whole industrial landscape keeps shifting towards being more autonomous, more intelligent, more adaptive, well, how quickly and effectively companies adopt and integrate these wireless technologies, that's really going to shape their competitiveness long term. If you're interested in digging deeper into this whole transformation, we absolutely recommend checking out the full analysis. It's titled Wireless Connectivity, Enabling the Next Industrial Revolution, prepared by the Alpert research team. You can find their presentation on the future of the wireless industrial revolution at the link provided in our show notes.